Hello, this is 44th part of explanation of my theory. Today our subject is finally COMPTON Experiment. Title: ARIDAŞIR'sTheory's theory's proof is COMPTON Experiment. According to my theory and my formulas. 1. Compton had assumed that he showed the interaction between the photon as a particle and the electron as another particle, and he formulated his experiment's results with respect to accepted physics theories. Whereas the Compton experiment results are concerned with the interaction between the two types of light that I put forward: single wave pulse from proton-bounded electron motion form and free electron motion forms successive waves. 2. I have said before that two types of lights, single wave pulse from proton-bounded electron motion form and free electron motion forms successive waves, can interact also. All X-ray graphs with characteristic X-ray lines, in fact, only can be shown with a continuous spectrum. This spike is characteristic X-ray, here continuous spectrum. All X-ray graphs with characteristic X-ray lines, in fact, only can be shown with a continuous spectrum. We cannot tear apart them wholly, and we cannot separate these two. Characteristic X-ray lines cannot occur without a continuous spectrum in the graphs. Single wave pulses cannot occur without free electron motion forms successive waves in the X-ray graphs. In fact, Compton's experiment focused on the characteristic X-ray line only and used the filters to separate it from the continuous spectrum. Compton had tried to tell the angular variation of a characteristic X-ray wavelength in the context of colliding and scattering particles. This characteristic X-ray sample was from the key alpha series, and its wavelength was 0.0709 nanometer. But other experimental data shows that the characteristic X-rays are isotropic. Therefore, characteristic X-ray from molybdenum at 0.0709 nanometer that had been used in the Compton experiment must be isotropic also. All X-ray graphs, continuous X-ray spectrum and characteristic line X-rays originally display as a whole here or here. Again, all X-ray graphs, continuous X-ray spectrum, and characteristic line X-rays originally display as a whole picture. In this picture, the continuous spectrum is anisotropic, and the characteristic line is isotropic. This line isotropic. Characteristic line, spike. Here, continuous spectrum is anisotropic. Okay. This result had shown experimentally without any explanation. 4. Compton's experiment's aim was to prove that the light is the photon particle, to manage that without being aware it had torn and thrown the most part of the page of the nature. It had tried to tear and throw the continuous spectrum, to filter and to separate the, say, characteristic ray sample of molybdenum that comes as key alpha line at 0.0709 nanometer by means of Bragg crystal or Bragg crystal-like equipment without being aware in an interaction between continuous spectrum and characteristic line and continuous spectrum that determinative on this line that makes it variable in the limited constant. Again, Compton's experiment's aim was to prove that the light is the photon particle, to manage that without being aware it had torn and thrown the most part of the page of the nature. It had tried to tear and throw the continuous spectrum, to filter and to separate characteristic ray at 0.0709 nanometer by means of Bragg crystal or Bragg crystal-like equipment without being aware interaction between continuous spectrum and characteristic line, and continuous spectrum that determinative on this line that makes it variable in the limited constant. The constant is, they say, in fact, Compton wavelength 0.00242 or 0.00222 nanometer. But according to my theory, it is elastic, limited constant, variable constant in its limit. In its limits, okay. I will tell you. Luckily, the nature continuous spectrum had managed to seep and slip through the hole of the Bragg crystal filter by breaking the Bragg's law, but not wholly. In 0.00221 nanometer constants limit, you say, Compton wavelength. Again, luckily, the nature continuous spectrum had managed to seep, glide, and slip through the hole of Bragg's crystal filter by breaking the Bragg's law, but not wholly, in 0.00221 nanometer constants limit. 5. Compton wavelength 0.00221 nanometer is a constant, according to me, that can change in its limit by the fact of free electron motion forms successive waves, varying with respect to free electron motion forms relocation, direction, velocity, and orientation. Shortly, the anisotropic variability of free electron motion forms successive waves makes this constant variable. How? Successive waves. Variability of successive waves of free electron, of relocating free electron motion forms successive waves variability makes this constant, say, Compton wavelength 0.00222 nanometer, variable in its limit. How? 6. I have said before that single wave pulse from proton-bounded electron motion form and free electron motion form successive waves can interact also. This constant's variation this is the constant. They say Compton wavelength. Okay. I have said before that single wave pulse from proton-bounded electron motion form and free electron motion forms successive waves can interact also. This constant's variation in its limits, you see, is one of the results of this interaction, according to my theory and my formula. Single wave pulse and free electron motion form successive waves interact when they are intertwined. When they intertwine. Here, blue circle is single wave pulse. Represents characteristic line, or characteristic line represents this, in fact, single wave pulse. And intertwined now at a certain wavelength only, okay? And when coincides two of that, here, these are free electron motion forms successive waves, okay, relocating free electron motion in this direction, 0 degree direction, remember, okay, I don't want to confuse your mind now. This constant variation in its limits is one of the results of this interaction. Single wave pulse and free electron motion form successive waves interact when they are intertwined. Intertwined. 7. This variation in a limit is the limited mimics of limitless variation. Wait a moment, please. This variation here again this variation This is representative wavelength of single wave pulse, and this is my formula for Compton wavelength as a constant for me, but limited. It mimics the free electron motion forms, limitless variability, wavelength variability in its limit. Okay. This variation in a limit is the limited mimics of limitless variation of free electron motion forms. Successive waves relates to free electron motion forms relocation values. Relocation of free electron motion forms velocity, relocation, velocity, direction, orientation. Shortly, the variation of successive waves, the variation of left side. Remember this variation from my former videos. Variation of, shortly, the variation of successive waves, values. What is values? Wave velocity, wavelength, etc. Shortly, the variation of successive waves determines the variation of this constant. Seven, they share the same angle. Look at that. They share the same angle for variation. Then I put forth that relation formula between two interacted lights. Here. I hope you see. Yes. Now, what this sketch tells us, this is my sketch. Yes. Here. Say we apply 20 kilovolt to an electron for gaining velocity, and this side, 0 degree side here, this is 90 degree side, this is 0 degree side, this is 180 degree side, okay, etc., 45 degree, yeah. Yes. Black circles are waves of relocating free electron motion forms, okay, and blue circle is single wave pulse that coincide with free electron motion forms waves, but at certain points, at certain intersects or intersection. Okay, here. When do this, these two kinds of light, this is the graph. Single wave pulse represented by this spike at a certain wavelength. Lambda represented the single wave pulse. Okay, here this is wavelength, intensity here. Now we apply, say, 30 kV, 30 kilovolt, for make the electron has greater velocity. In this zero direction, this is 90 degree, this is 0 degree. Remember my former video. And here, black circles are free electron relocating free electron motions waves, and blue one single wave pulse. Angular dependence, characteristic X-ray and continuous spectrum that I put forth. Don't forget that. Okay, and in the direction of 0 degree, wavelength shorter than this, and this coincidence angle here larger. Okay, because of that. Same lambda single wave pulse, same lambda single wave pulse. Okay. At these lines, they coincide. These two kinds of light coincide at this intersections. Here at this intersections. This is slower electron motion forms successive waves. Here has greater velocity free electron relocating free electron motion forms successive waves, and this is the graph now. Look at that differences. Okay. Angular dependence. Same representative single wave pulse wavelength here, here. And if electron motion form is not sufficient velocity, we cannot see this interaction and characteristic single wave pulse line. Okay, like this. Here, and this is the if single wave pulse of proton bounded electron motion form smaller than in all point successive waves wavelengths, we cannot see a spike. Okay. Now, here, COMPTON experiment, but I changed the explanation. This blue side is single wave pulse from proton bounded electron motion form. Okay. And here black circles, successive waves of relocating free electron motion forms, successive waves, okay, into this direction. This is 90 degree, 45 degree, 0 degree, 30, okay. Say in any point intersects, but now in COMPTON experiment this is not important, okay. Here these parts, Bragg crystal here, I will color with blue. 1, 2, 3, 4, Bragg crystal. Okay. Bragg crystal. But Bragg-like crystal, okay. Here X-rays from here, don't forget. Okay. Graphite, then. Okay. According to me, this is the direction of successive waves of free electron motion forms, according to my theory and my formulas here. Black circles, okay. At this point, lambda alpha is equal to lambda n minus delta lambda, remember. At this point, lambda alpha equal to lambda n minus delta lambda cosine 90 degree, remember, okay. And this blue one, single wave pulse, okay. This Bragg or Bragg-like crystal, after the Bragg crystal in the direction of 0 degree, its pulse, this pulse filtered. But as I said before, as I said now, not wholly, okay. Then, because of it is greater, its wavelength is greater than this point, free successive waves, there is only one characteristic filtered line graph. Okay, this is not, there is no continuous spectrum. There is no continuous spectrum. This is 0.0709 nanometer, normal, original, single wave pulse, equal to 0.0